Binomial expansions, part 1. The expansion of a plus b to the power of n, where n is a positive integer. And we have our two terms, the first term, the second term, and this must be a plus in between. So to expand 1 plus 2x to the power of 3, we should put 2x in brackets. So wherever we write 2x, it will be in brackets. So we've got the first term in the brackets, which is a 1, and it starts off with the power of 3, that's what we see here, to the power of 3, 2, 1, and you go all the way down to 0. And then the other term, the 2x, will have powers in reverse order. So if we just line up the terms so they're in columns, so 2x in brackets to the power of 0, 1, 2, 3, and then we have the binomial coefficients, which we can get from Pascal's triangle, like this. First row for the power of 1, second row for a power of 2, third row for the power of 3, 1, 3, 3, 1. The alternative is to use the NCR. Here's NCR on the calculator. We can use this. So 3C0, 3C1, 3C2, and 3C3. And when we multiply these together, that will give the first term in the binomial expansion, second term, third term, fourth term, and we get these. And the terms here are in ascending powers of x, or if I reverse them, in descending powers of x. And we have a fixed number of terms. If we do a full expansion, we have exactly 4 terms in the full expansion of 1 plus 2x to the power of 3. In this example, we want to expand in ascending powers of x. We have a minus here, so we need to take care of that first, like this. So wherever you write the 3x term, you must have a minus before it and the whole thing in brackets. Okay, so I've got my minus 3x term, ascending powers of x, so powers of x going up. So to the power of 0, you always start from 0. 1, 2, 3, you stop when you reach that value. And then for my other term, the 1, in reverse order for the power, so 1 to the power of 4, 3, 2, 1, and 1 to the power of 0. And then this is the fourth line in Pascal's triangle, or we can use these binomial coefficients using the NCR function from the calculator. And as an example, if we multiply all of these out, you get this term, minus 108x cubed. Be careful with the negative values in brackets. Make sure you use brackets everywhere to avoid making errors. For instance, without brackets, this term would look like this. You wouldn't think of doing minus 3 to the power of 3. You need the brackets. In this example, we're looking for a specific term in the expansion, so we don't want all of the terms, we just want one specific term, and then we can find the coefficient of that particular term. And there's 2 methods we can use. And the first one is to pretend that we're going to do a full expansion, but to stop at the term that we're looking for, which is the x cubed term. You've got the x squared term here, the linear term, and that's just a constant. And then multiply all of these together, and once we've done that, we'll have our specific term, and here's the coefficient of the x cubed term, which is what we're after. Now there's a second method. This is in the formula book, and this will give you any term you like in the expansion. So we start off with what we're going to expand. And if we compare terms, the a is 2, so I need to put 2 here. B is minus 3x in brackets, so I need to put minus 3x in brackets here. And n is 8, so I need to put 8 here. and here. The only unknown is the r, and we can figure that out at the end. So if we just substitute the various terms in, we get this. Now to get an x cubed term, if I look at all of the terms I've got here, this is the one with x in there. To get x cubed, r has to be 3. So I'm going to replace the r with a 3, and then I can work out and simplify everything else that I need from there. And as before, we have the same coefficient of the x cubed term.